Welcome to Gateway Learning Center with me, Nathan. Today we're going to look at chemistry under more concept. So under more concept, we'll look at some of the parts of more concepts. We'll talk about mass to mass calculation, percentage yield, and limiting reagent. So I have a question which will cater all the three parts in one question. So the question is on the board. The question reads: magnesium oxide reacts with dilute sulfuric acid as shown below. So this magnesium oxide then reacting with sulfuric acid to form magnesium sulfate plus water. So I've been given 600 grams of magnesium oxide, which was reacted with 980 grams of dilute sulfuric acid. So the questions are: the first one, determine the limiting reagent in the reaction above. Then B, calculate the mass of magnesium sulfate that was obtained at the end of the reaction. Then C, if 1080 grams of magnesium sulfate was obtained at the end of the reaction, calculate the percentage yield. So this is the question which will help us to understand the mass to mass, percentage yield, and limiting reagent. So we'll start with limiting reagent. Whenever we are calculating limiting reagent, the first thing is to balance the weight or the chemical equation given. So if you don't know how to balance the chemical equation, it means this question cannot be unknown. So we're going to check if the equation is balanced. So here we have 1 mole of magnesium. On the other part, we also have 1 mole of magnesium. And on the other part, we have also 1 atom, then plus 4 atoms, which makes 5 atoms. Then here we have 1 atom plus 4 atoms, which makes 5 atoms of oxygen. Then 1 sulfur, then we also have 1 sulfur, 2 atoms of hydrogen, then also 2 atoms of hydrogen. So from the equation itself, the equation is already balanced. Therefore, from here, we can now look at limiting reagent. Now, remember that limiting reagent is a reactant which determines how far the reaction will go in the process. So we need to understand that limiting reagent is only determined from these two reactants. So we want to find out which one will limit how far the reaction will go. So now we'll get 1 mole of magnesium oxide. Then also have 1 mole of H2SO4, which is sulfuric acid. So this 1 mole and this 1 mole is coming from the balanced equation. It means that if we don't have any number which are balanced, we have already 1 mole. Then from here, the next step is to find the number of moles for this magnesium oxide, also the number of moles for sulfuric acid. Therefore, we say magnesium oxide, so number of moles is equal to mass over molar mass, Mr. Then also here, we have H2SO4, where I will say the number of moles is equal to mass over Mr. So the masses have been given for both reactants. So we have 600 grams of magnesium. So put 600 grams of magnesium over its Mr. So how do you find out the Mr. of magnesium oxide? So I'll try to use this space. Okay, I'll use this space. So now, since we have magnesium oxide, to find its Mr., we know that we have 1 times 16, the mass number of oxygen, then 1 by 24, the mass number of magnesium. So 16, if you add here 16 plus 24, of course 10, 1, 3 plus 1, 4. So 40. So 40 grams per mole. Then we come here. So on the sulfuric acid, we have the mass of sulfuric acid, which is 980. So 980 grams over the mixture of sulfuric acid. So we have H2SO4. So 4 by 16, the mass number. Then sulfur 1 by 32. Then hydrogen have 2 times 1. So if we add this, so 16 by 4, we are getting 64. Then 1 by 32, we are getting 32. Then 2 by 1, we are getting 2. Then we add. So here we are getting what are we getting? We are getting 8. Then here we are getting 9. So we have 98 there. So 98 grams per mole. Therefore, from here now, since we know that now we can do the simplification, let me get my target. Alright, so we are saying 600 grams divided by 40, so I'm going to cancel grams, I'm going to cancel grams. Then 40 into 600, so 600 we divide by 40, we're getting 15. So for the sake of proper calculations, let me bring my calculations this side. Let me manage my space. Alright, so we have 600 grams over 40 grams per mole. So grams height, then 600 divided by 40, we're getting 15 moles. Then the other part, we have 980 grams over 98 grams per mole. So we're cancelling out the common units. So of course 98 into 98, we're getting 1. Then 98 into 0, we're getting 0. So we have 15 moles and 10 moles. From there, we need to come back again to the equation. So since we have 1 mole and 1 mole, this mole you can divide by 1, also here by 1. So 1 into this, we're going to get the same numbers. So 15 moles, even here, we're going to get 10 moles. So those were the final ratios which we have gotten. Now, for example, if after we balance the equation, then we discover that here we have 2, here we have 3. The same number which we use to balance the equation should be used here to divide. Now, since we have 1 more and 1 more, they are going to give us the same numbers. But if we had different numbers, it means that those numbers should also be used to divide here, then we get the final answers. This is a reason why if you don't know how to balance the equation, it's very difficult for you to get this question correctly. So after we have found the original answers or the final answers, the next thing is we need to know which number is bigger than the other. So since we have seen that we have 15 moles, which is representing magnesium oxide, we also have 10 moles, which is representing sulfuric acid. So the small number we have here determines how fast the reaction was going or will end. So we're going to conclude to say, therefore, sulfuric acid is the limiting reagent. Reason, because it has small number of moles. So sulfuric acid is a limiting reagent because it has small number of moles. Therefore, the excess reagent, the excess reagent. To calculate excess reagent, we need to understand that you subtract 15 moles minus 10 moles. So 15 moles was in excess, which remained unreacted. Therefore, sulfuric acid was in short supply. It determined how far the reaction was. So this is how we answer limiting reagents. That is how we answer limiting reagents. So simple way, the first thing, remember, you balance the equation. After you balance the equation, you just get the reactant side to find the limiting reagent. Never should you make a mistake to cross to the product side. When you do that, the question cannot fit you. Alright, so that is the answer. The second one, calculate the mass of magnesium sulfate that was produced, I think, at the end of the reaction. Calculate the mass of magnesium sulfate. So this was our equation. We have magnesium oxide plus sulfuric acid to produce this. So I want to find out now how much mass of magnesium sulfate was produced. So for us to find this one now, remember, we are going to use mass to mass calculation. So this question will help us to answer that part. Okay, I will now remove this part. Hope you have understood. The next thing, mass to mass. So calculate the mass of magnesium sulfate. We have this part. Now, which one can we get? Which can help us to find this one? So whenever I want to find the product which was obtained at the end of the reaction, you need to understand that you need to get the reactant which determined how far the reaction was, because that reactant or its moles was reactant. But if you make a mistake to get the other one, it means that it cannot produce the correct figures, because it has other moles which was in excess, which remained unreacted. So always we get the reactant which determined how far the reaction was. So in this question, we have concluded to say sulfuric acid was the limiting reagent. Therefore, we will say H2SO4 will be equated to now the product magnesium sulfate, which is a salt. So now this one, we're going to answer mass to mass calculation in a shortcut way. We're going to find the mixture for this one, the mixture for this one. The entire balance of the equation had each mole for each reactant and product. Therefore, we know that we had 1 mole for here. So 1 mole times, then we find the mixture for this one, which we have already calculated, which gave us 98 grams per mole. Then we also find mixture for this one, of course, not we have 1 mole. Then multiply by, now we find the mixture for magnesium sulfate. So magnesium sulfate, so of course 4 by 16, which is 64. Then sulfur 1 by 32, which is 32. Which is 32. Then magnesium also has the mass of what, 24. So 1 by 24, which is 24. So if we do calculations here, 4 plus 2, we are getting 6 plus this one, we're getting 10, so 0, 1. Then 6 plus 3, we're getting 9. 9 plus 2, we're getting 11. 11 plus 1, we're getting 12. So 120. So 120. So 120 grams per mole. That is our calculation. So you can cancel what is common. So grams is also common. This number of moles is also common. Again, moles and moles are common. So I've cancelled everything. Now, After finding this one, since we got sulfuric acid, you're going to get the mass of sulfuric acid, which is 980 grams. Then here we are going to put X because we're finding the mass for magnesium sulfate. We cross multiply. So after we do cross multiplication there, okay, so from here, now we are saying, since we have cancelled everything here, so X will multiply by 98. We are getting 98X. Then 980 grams multiplied by 120. We have 120 multiplied by 980 grams. So we divide by 98. Also divide by 98. So we're going to cancel these. So X is equal to, now we can calculate. Remember, we only have 1 unit there, so we should automatically give us the units for our answer. So we're saying 120, you multiply by 980. After that, our answer, we divide by 98. So I'm getting 1,200 grams. So 1,200 grams was the mass of magnesium sulfate which was obtained at the end of the reaction. Alright, so that is how we answer mass to mass calculation. Then the last one, the question is demanding from us to find the percentage yield. So I'll just bring a topic on how to calculate percentage yield with different examples, of course. But from the explanation, I'll try to, by all means, to touch all the angles. So we have 1,080 grams of magnesium sulfate. So the key part is this one. Magnesium sulfate was obtained at the end of the reaction. Calculate the percentage yield. So we understand that percentage yield is equal to what? Actual yield over theoretical yield. So actual yield over theoretical yield, then you multiply by 100%. Therefore, we will say percentage yield is equal to actual yield over theoretical yield, you multiply by 100%. So this is the formula which we use whenever we are calculating percentage yield. Now, we need to understand again that theoretical yield is always more than the actual yield due to some conditions which takes place whenever this actual yield is getting obtained. So theoretical yield will always be bigger than the actual yield. From there, we have been given this 1,080 grams. So this 1,080 grams is the actual yield which was given in the question. So we'll say percentage yield is equal to 1,080 grams over the one we have calculated now, because this one is the mass for magnesium sulfate. And in the question, they are asking us to find the percentage yield of magnesium sulfate. So if this one is wrong, it means even this one will be wrong. So 120 grams, then multiplied by 100%. So when we do mathematics there, I say 1,080, then we divide with 1,200, then we multiply by 1,000, by 100, we are getting 90%. So 90% was the mass of magnesium sulfate which was produced. Meaning that this 10%, which is not making this percentage to be 100, has been the 10% that has been lost in different situations. So that is how we come up with the answer and mass to mass calculation, limiting reagent as well as percentage yield. So more concept, it's not that much difficult, provided you know the basics of it. Then it will be very simple for us to come up with the answers. So next time we shall talk about concentration and how to find empirical formula. So for now, we call it a day.